We've been talking about the force on a charged particle moving through a magnetic field. And we talked briefly about the direction of the force. And we said it's kind of strange. It's perpendicular to both the motion of the charge and the direction of the magnetic field. I'm going to write that here. The direction of the force is perpendicular to the motion of the charge and the magnetic field. So for example, if I had an electron moving to the right in a magnetic field that was pointing upward, my force would be perpendicular to that. And the only things that are perpendicular to that are out of the page towards you or into the page away from you. We have to determine which of those two things is right. We're going to use our right hand. We're going to use the right hand rule to determine the direction. We're going to use the fact that our thumb and our fingers are perpendicular to our palm to find the force, because that force has to be perpendicular. Now the rules are going to seem a little confusing at first, but once you practice it, it actually isn't too bad. When we do it, we're going to use our thumb to represent the movement of the charge. Okay. We're going to use our fingers to represent the magnetic field, and our palm will then push in the direction of the force on a positive charge. Now in order for this to work, we have to make sure that our thumb, our fingers, and our palm stay perpendicular to one another. So I can't bend my thumb in this way, I can't bend my fingers down like this. I have to keep my palm and my fingers and my thumb all stiff like this. So as I'm moving them around, I have to move them around so that my hand stays like this. I can't bend things like this for this rule. Now, our first example then shows a proton moving to the right in a magnetic field, and the x's mean into the page. So we use this rule. The thumb is the motion of our charge. Our charge, the proton, is moving to the right. So my thumb points to the right. My fingers point in the direction of the magnetic field. So my fingers have to point into the page. So if my thumb is pointing to the right, my fingers are pointing into the page, I end up with this. And my palm is pushing up toward the top of the page. So the force is going to be up towards the top of the page. So try that yourself. Thumb this way, fingers in toward the page, my palm pushes up. The way I use this, the thing I use to help me remember this is there's one charge in the problem, okay, and I have one thumb. There are many magnetic field lines, and I have many fingers to represent those. And a force is a push, and my palm pushes, so that's going to tell me the force. Next example, okay, we have an electron moving downward in an electric field, and the dots mean out of the page. So my thumb has to point the way the electron's going. I have one electron, one thumb. My thumb points down. Now my fingers have to point out of the page while my thumb continues to point down. So I can't do something like that because my thumb is pointing up. So my thumb is pointing down. My fingers turn so they're out of the page. And if I walk around over this way, it'll be a little easier. My thumb is down, my fingers are out of the page, and my palm is pushing to the left. So we would say there's a force to the left. But there's a little trick to this problem. For this particular problem, it's an electron, and we said that this force is on a positive. Our palm pushes in the way a positive goes. So if the positive would go to the left, the electron would go to the right. So the rate of force on an electron is going to be to the right. Top of the page, we have our next example. Okay, again, you might want to try this one on your own, see if you're getting the same thing I am. Okay, so in this one my electron is moving downward. My thumb shows which way the charge is going, so down this way. My fingers are pointing to the right, so my fingers point this way. And now my palm is pushing out of the page towards you. However, if you remember, this is a negative charge, so it's going to go the opposite way, so it's going to go into the page. So we'll write force is into the page. And then our last example, the electron is moving to the right and the magnetic field is to the right. And I said I have to keep my hand like this. I can't do that for this problem. Okay, the electron's this way and my fingers would have to go this way. But if you remember, when they're parallel, the angle between them is 0. And if I think of F equals QVB sine theta, the theta is 0, the sine theta is 0, and I get no force. We talked about that before. If they're parallel, there's not going to be any force.